Okay, so we got 3 more graphs to take a look at. So again, if I strip the next one of everything around it, right, what we're basically looking at is 2 to the x power. So we're basically talking about another growth model that's being transformed. So that function model, right, goes through 0, 1, 1, 2, 2, 4, and 2 to the x behaves pretty much like the function that I have in red. So what are the transformations that are occurring to it? Well, let me go ahead and rewrite this so you can see it better, right? This is negative 2 to the x plus 3. And what we're doing here is we're putting a negative in front of the function and then adding 3. So we're negating y values, which means we have a reflection, right, through the x-axis. And the plus 3 means that we're actually moving, the plus 3 means we're moving up 3. So behaviorally what's happening, right, is that this function, right, let's just manipulate this data point right here, right, because of the negative it's going to reflect through the x-axis, so down here, but then it's going to shift up 1, 2, 3. So that's where that point's going to be, right? This next point, right, it's going to shift, it's going to reflect through the x-axis and then shift up 1, 2, 3. Right? Even this point here, I think that would be a half. It's going to reflect and then go up 1, 2, 3. And because we're shifting up, that means that the horizontal asymptote is now going to be occurring at y equals to 3. And because we reflected through the x-axis, right, this is what the behavior of the graph is going to look like. All right, it's actually the positive infinity behavior is going to flip down and go down to negative infinity in that case. All right, so there is what that new graph is going to look like. We obviously have, right, a new y-intercept. We actually see that there is now an x-intercept in this graph. How to find that, we'll discuss that later in chapter 6. But right now we can at least see there is going to be one, right, as opposed to there is not one, there is not one. As a matter of fact, even here, right, after we transformed the graph right and down 3, we created an x-intercept. So how to find those will come later, but we've got that. Right, so the next graph, we've got that very famous exponential function. Remember, e is just a number, like that's about 2.7, so it's definitely bigger than 1. I see that it's raised to the negative x power, so I definitely have a decay model. All right, so what's a decay model look like? Well, again, it doesn't really matter what the base is, right? It's going to be going through 0, 1. It decreases really fast and then starts to decrease really slowly. So there's basically our shape, all right, of a decay model, right? So that would be e to the negative x all by its lonesome. But what we're doing is we're adding 2 to it. So that means that this graph is moving up 2 units in upward motion. So first of all, what that means is that our y-intercept, or excuse me, our horizontal asymptote, right, is going to be moving up to y equals to 2, right? And then this whole graph is going to shift up 2 units. So as everything shifts up 2 units, we're going to get that graph that's in black. It's basically the red graph shift up 2 units. By the way, I think I forgot to answer, the domain again is everything, and in this case the range is from negative infinity to positive 3, right? Because of the action, the fact that the negative f of x created a flip-flop to the x-axis. Here the domain is still everything, right? And the range is from 2 to infinity, right? So there's a quick sketch. The next one, again, if we strip everything away from it, right, what we're basically looking at is 2 to the negative x. And so again, we have another decay model. What's happening to it? Well, this 3 tells us that we are basically vertically stretching it. And that's, you know, that's not really a big deal for an exponential model, because it's, or even a decay model, because it's going to infinity really fast. But you can just imagine what's happening is the graph is stretching out by a factor of 3. The -1 means we're moving down 1. All right, so this graph, all right, again, if we start with 2 to the negative x, goes through 0, 1, right? We actually can plot some nice points for that. So here is 2 to the negative x in red. So what's happening to this graph? It's being stretched a little bit and moved up 1. So 1, if you kind of put it in there, right, we're going to get 3, and then it's going to go up, down 1. So we'll be about right there. And the rest of the graph, right, since we're going down, dang it, we're going down 1, my horizontal asymptote is going to be y equals to -1. So just manipulating the point here, it's going to be multiplied by 3, right, which makes it 3. And then going down by 1 puts us right there. And now I have it in the right spot. And so in this direction, it's going to be getting closer and closer to y equals -1. And in this direction, it's basically going to explode. So you kind of see the graph stretching a little bit, right? And you see it shifting down a little bit, right? And so there's a really quick graph of that. In terms of its domain, again, it's defined for everything. And its range is now from -1 to infinity, because that's -1 there. Okay, so there are some quick sketches. Hopefully that was also some good review of a 3.5 topic. I cannot begin to express how important it is. It's been a while since we've seen those, but transformations play a huge role in being able to, when you get really good at them, you're even faster than your calculator, right? You know, if I wasn't explaining stuff here, I could have probably graphed all these graphs faster than somebody probably could have entered that on your calculator. So it's just knowing what you're looking for, again, what's the basic function, what transformations are occurring around it, right? And then getting a quick sketch. And in this case, the things that are really changing are the asymptote behaviors changing, the y-intercept is possibly changing, right? Which means we create some x-intercepts in some cases, so the range is changing. Those are the big things that we're going to be constantly looking for, but the general behavior is pretty much the same, with the exception of that guy, right? We went from a growth model that's constantly going up to a model that's now constantly decreasing. But that's just because of the behavior of the reflection that we did. All right, so that settles that. Let's go off and do some more stuff.